Good afternoon, everyone. My name is Jonathan Flack. I'm a cloud and security architect at the Air Force Research Lab. I work for a company in Dayton, Ohio called Mile Two, and I'm a named resource of the United States Air Force. I'm here today with the head of architecture from Google, Andrew Tash, and Brandon Campbell from the Mandiant team working with the DoD CIO's office and the Zero Trust Portfolio Management office. Before I get started, I'd like to extend a thanks to my mission owner, Dr. Dan Berrigan at the U.S. Air Force Research Lab. He's been hard at work on this problem since before I became involved a few years ago. He's a civilian researcher. He's become a good friend. And I'd also like to thank John Kindervag, the original creator of Zero Trust, another good friend of mine, and Randy Resnick, the director of the Zero Trust Portfolio Management Office at the DoD CIO. Without their contributions, none of what we're talking about today would have been possible. So to kick this off, in 2022, AFRL Research and Development had kind of come to a point of existential crisis in their ability to deliver cutting-edge technologies to the 14,000 researchers that we support. While it's true that we had solutions in place, they were not serving the end user's requirements, and rather than build what we thought was needed, we went directly to the users themselves and we asked them. Thankfully, my mission owner, Dr. Berrigan, he is himself a researcher. He's a materials scientist and he knows how to ask these kinds of questions of the research community. And what we got back from them was pure gold. Some of you are probably already familiar with these problems. Acquisition of R&D computers can take up to 6 months. We can't evaluate small business capabilities with government data. There's no place to efficiently collaborate with the defense industrial base and academia. Cloud does look promising on the surface, but doing research in government cloud requires our researchers to have IT certifications, and each R&D program then has to contract with cloud SMEs to comply. There's no money for that in research. Accessing a government cloud costs more than some entire program budgets. And government cloud services often lag behind what's available in the public sector. So how can research be relevant with outdated services? In order to ensure we'd done our due diligence, we looked to see if there was something in the current implementation space that was misconfigured or simply could be refined to improve the capability for our end users. It turned out that that wasn't true. Finally, we asked, how can we achieve our new objectives securely, whether we put it in the public cloud or the private cloud? And this is what began our journey. A few years ago, the Digital Capabilities Directorate was formed at AFRL. It now supports 14,000 personnel. The one thing that it's targeting is saving all of our researchers' time. It's the one thing that we have in equal measure to all of our adversaries. China, Iran, Russia, North Korea, they all have the same amount of time we do. We decided that in order to secure the work that we needed to take a completely different approach to what we were doing. But in order to solve this problem, it needed to scale. We've all seen something like this effort before. A clever contract team, they move heaven and earth to provide some solution for a challenging problem with a point solution. These teams have impact, no doubt, but our objective was to take these lessons learned and amplify their scale. However, scale without agility leads to inflexible, stagnant capabilities. This doesn't work for research either. So how do we maintain relevance to our customers, the researchers over time, and still maximize return on investment over many, many years? We took a platform-based approach. We applied a highly agile operations philosophy we literally appropriated from some of the companies that inspire the work we do today. Google, Amazon, Microsoft. And we built a continuously evolving cloud workload environment to meet the demands of our customers. But platforms are complex. So how do we safely manage the entire life cycle with so few resources? Site reliability engineering. This is the discipline of treating software operations or treating operations in the cloud as a software engineering problem. So what is the site reliability engineering get us over console-based ClickOps that most teams are used to? Every change to every resource is captured in GitOps. Issues, merge requests, maintainer approvals, all 100% captured and accountable. This is really great for ATOs. We're closer to the user demand signal in what we deliver. The users tell us what they need, we code it, and we deliver it. We safely release capabilities faster, get value early, user feedback, quickly applying lessons learned, all to the benefit of our end users. And field adjustment to these workloads are faster and easier. Evolution is now a natural part of our core philosophy, and it's accelerating innovation at scale. What have we delivered to date? We have over 250 active ongoing research projects in Google Cloud. We have over 4,500 active users, including AFRL, NASA, and Space Force researchers. We support interaction with the academic community, allied foreign national partners, and multiple DoD contract teams, all collaborating interactively in the exact same space. To foot stomp the problem of GovCloud services trailing public clouds, AI is having its breakout moment. We're investing billions to gain a significant advantage over our adversaries, and access to these capabilities now could not be more present. Yet across these capabilities in various GovClouds, it's been either impossible or severely constrained by resource availability. This is one of the primary reasons that we chose to build in Google Cloud. Google Cloud's deployment methodology is specifically very different than their competitors. They've chosen to provide GovCloud level capabilities through cryptographic isolation rather than physical isolation. This allows us to hide workloads in plain sight with retail customers in their public cloud with full cryptographic isolation approved by DISA. This decouples us from the resource constraints that we see in most of the government clouds and provides access to resources that our researchers would otherwise either have to compete for with other agencies or not have available to them at all. As part of a $3 million SBIR to deliver new accelerated material science software, we pioneered a process to deploy externally developed cloud software on AFRL's Google Cloud platform, allowing rapid development of mission-critical software to our S&Es. This allows the S&Es at AFRL to collaborate with institutions, access, simulate, analyze, and share results on AFRL-controlled resources in Google Cloud. This capability now supports research in density, functional theory, molecular dynamics, machine learning, learned, MD potentials, and using ML frameworks to train on public materials databases, all of which would not be possible in a government cloud environment. All with zero trust controls and workload microsegmentation to de-risk the entire ecosystem. Every workload is in its own project or secure namespace in Kubernetes, its own network with its own controls, following easily maintainable, repeatable patterns to secure every data, asset, application, and service element, and continuously verifying controls at layer 7. How do we know our controls work? We invited the bad guys in to try and break us. And we gave them our admin credentials. Red and Purple Team exercises over 2 continuous months in collaboration with the DoD CIO's Zero Trust Portfolio Management Office, the National Security Agency, DevCom, and Mandiant confirmed all of our efforts. And our assessment with the DoD CIO's ZTP FMO passed with a 100% pass rate. We're doing all of this to de-risk this problem for you. So if any of you in the DoD space want access to the code that we've developed here, it's free. Just ask us. We're here to accelerate your mission. That's the job of research. So I'd like to get a bit more tactical about how we did this, the elements of the platform. The first job for us was to keep it simple. Large cloud ecosystems like this are going to complexify themselves without us adding any more to the problem. Experienced teams understand that simplicity is critical for maintaining scale management. So we built on a rock-solid foundation of Google Cloud native capabilities, avoiding almost all third-party integrations, particularly for identity. And we all know identity is at the core for Zero Trust. Fewer moving parts means fewer failure points, lower costs, and faster release cycles. Here's what we focused on. Maximum OPSEC philosophy, with operations physically segmented from their workload environments by impact level. Centralized cloud native identity management federated from the DoD into a Google identity. This is similar to setting up a one-way trust with Azure Active Directory. This unlocks all of Google's native Zero Trust capabilities, and I'll remind everybody here that Google's been doing Zero Trust since 2008. They're very good at it. Self-hosted GitOps-based self-documenting operations map directly to change management or risk management in GitLab. Secure cloud-native development workstations for developers. This is very important. We build our workstations using Docker containers. The base distribution that we use is from ChainGuard. It uses a distribution called Wolfie. We also use Google Distro List for a lot of things where we don't need a user interface. These workstations provide no opportunity for users to escalate permissions. There's no root. There's no wheel group. There's no option to sudo. So once you're logged into these systems, you are locked into what you're allowed to do and nothing else. Fully declarative infrastructure as code. This is the most important point. We describe every configuration in code. It goes through a formal GitOps process to get into production. Everything is documented, has a track record, and is accountable down to the single character stroke in the code base. It's all automated. We have integrated SecOps and drift detection pipelines. And for those that are familiar with working with infrastructure as code, drift detection is where we run pipeline jobs in GitOps on a half-hour basis to ensure that everything in our deployment environment is exactly as it's intended to be configured. If any detection fires, it goes to the SOC, an alert is turned into an incident in the SOAR, and it's immediately processed by somebody in the security operations team. We do supply chain security scanning and analysis according to NIST 800-218. We provide self-hosted artifact registries for all the development teams with integrated artifact analysis. We do continuous workload posture monitoring for everything in the deployment space. So if a new CVE hits the National Vulnerability Database while you're sleeping, when you wake up in the morning, there's an alert on your dashboard when you log in. We know exactly how to update the workload, and it can be canaried in Kubernetes within an hour. We have well-defined golden paths for build and release engineering. So when development teams come to us from one of the directorates and ask, how can I deliver this new capability into production for my researchers? We provide them the exact pathway to get that deployed and inside the ATO boundary. This simplifies things. We terraform everything for them. I can have a team up and working inside this environment in less than 6 hours. That includes all of the build and release engineering tooling, the build pipelines, supply chain security for all of the artifacts that they bring into our environment, all of the GitOps, all of the branch protection rules, everything that they need as developers to hit the ground running. We have well-defined organization-wide policy as code. Org-wide access policy levels map to governance as code, and conditional access through cloud-native access points, IAM, and other resources. So for those of you familiar with doing IAM role bindings, we put conditions on those role bindings. If you're not on the machine that the government issued you, I can deny you access even though you have roles assigned to you that utilize those IAM roles. If your machine doesn't have the screen lock enabled, I can block you. If you're coming from outside CONUS, I can block you. This unlocks a lot of potential for remote work. And when working with researchers and academics, this is critical. We provide continuous monitoring. Our SecOps SIM and SOAR as previously. Now I want to talk about how we actually did this tactically. This took 2 years for a team of 8 people to get into general availability. So if you're interested in doing this in your environment, you'll have to accept the fact that you're going to do some yak shaving. These are the tasks that you have to do to get to the task you actually think you need to get done. You'll have to be patient and deliberate, and it'll take time to instantiate all the necessary resources and automation. But once you succeed, the benefits will live forever. The step one for us was to define the roles for all the site reliability engineers. These roles are broken down by target enclave, so these are replicated across IL2, IL4, IL5, and beyond. We have reporters. They can access and view the code base, create issues. Developers who can create feature branches in the code base, suggest changes, and create merge requests. Maintainers who are responsible for maintaining readability in the code base. These are expert level developers who are very fluent in the code base and in the area of the code base in which they work. They approve every merge request only after code review. Even maintainers are required to request code review by other maintainers. Nothing gets into the main branch without it being reviewed. And then we have admins, which carry a unique admin identity. There's no email or any other services associated with these unique identities, and they're for the very rare cases when we have to actually put hands on console to manipulate a configuration. Step 2, we needed to create an isolated, secure, multi-governance operations deployment. We needed dedicated cloud-native operations, leveraging cloud-native access points, cloud-native IDE workstations for the developers, site reliability engineers, and we needed self-managed GitOps, as well as deployment automation using Terraform per impact level and per governance enclave. This is a simplified view of what that looks like. This is the main entry point for developers into our ecosystem. They interact with self-hosted GitLab through a cloud-native access point or to cloud workstations in a completely separate project on a completely separate VPC with no peering or connectivity to the main operations asset environment. We have Terraform resources in a dedicated project, which provide all of the configuration for these resources, as well as deployment automation for all of our impact level environments. I want to talk a little about how we facilitate communication between different parts of the architecture. We utilize a service that Google is unique in Google called Private Service Connect. This is a service level connection that facilitates the communications over a dedicated port or protocol for TCP or UDP services where every single packet is authorized in the connection between the two VPCs. There is no peering. This provides a connection point from one VPC network representing the consumer's intent to consume a service, the service connection, to provide the endpoint for the service, defining the service, how the service is made available to consumers. Every single request, as I said, requires explicit authorization for the traffic to flow between the service attachment and the service connection. And the secure connection is established without requiring any peering relationships between the networks. The next thing we needed to do is make sure that our perimeter was secure. We use two technologies called Identity Aware Proxy and Access Context Manager to enforce these zero trust controls. Researchers regularly access resources in Google from on-premise networks, Dren, Nipper, even remote workers. Others are working with contracts teams that may require a number of offsite locations. We needed a way to enforce these perimeter accesses to our cloud resources and improve upon the signal strength for various data inputs to the policy enforcement controls. This is where Identity-Aware Proxy and Access Context Manager come into play. IAP is Google's identity-based access control for applications and TCP services. It verifies who you are before granting access at the perimeter, ensuring that only authorized users can connect via TLS, SSH, RDP, or other services. Think of it as an identity check at the door, making sure that only the right people penetrate your perimeter. IAP intercepts the incoming requests at our software-defined perimeter and verifies the user's identity assertion rather than directly forwarding requests to back-end services. It helps me understand who's really putting packets on my networks. We then enrich these controls with context. These contexts are governance-driven. Access Context Manager reinforces that signal provided by IAP by continuously evaluating access requests based on both identity and context. By evaluating access requests against access level policies we maintain in code at the organization level. It makes these decisions through a series of granular access level definitions using various attributes like location, device posture, security health, etc. This combines with IAP to help make more informed access decisions by adding contextual awareness to the authentication process at each public-facing TCP service endpoint. Only after satisfying the authentication requirements enforced by IAM and satisfying the access context policy condition on the endpoint is the traffic allowed to flow down to the underlying backend services, in this case GitLab or Netbox. So what does this look like in practice for the SREs or the developers? It's pretty transparent. When they log in, they see the homepage of our GitLab environment. Issues typically created using biweekly planning sessions approved by the government officials. Changes are requested using these issues. They're assigned to developers. We then issue them a cloud workstation to do the development work in, where they then code the change to the operational system. They then submit a merge request, which is then reviewed by a maintainer in the platform, approved, and then applied with Terraform. So looking at the operational mission space, this is that operations environment. All of our code lives here. This is where we deploy into each of the operational mission spaces at each impact level. Terraform services and operations are used to declaratively instantiate all the target resources. And for those of you who aren't familiar with the difference between imperative and declarative configuration, it's an important distinction. With imperative configuration, you must actually reach out to the target resource that you're configuring and manipulate its configuration. With declarative configuration, we're calling an API in Google and telling it what we want, and then Google's API then facilitates that request, configuring things as we've declared we want them configured. This is a much more secure way to do ops. There's no connectivity or peering between this operations environment. We hit the API over Google Private Access. This is facilitated by our own internal private DNS zone files, which have the record sets or the A records for the Google API endpoints in that private zone. Nobody who's not on one of the networks that are authorized to consume the records in that zone file can access it, so they don't know how to hit the API. And those API endpoints aren't exposed anywhere else in our ecosystem. Terraform services then deploy entire enclaves in a matter of minutes. So Within our IL4 workload, I'd like to dive in a little bit deeper about how we're leveraging many of the same capabilities to accelerate the work of our development teams. First, before we get started, I want to talk about one of the other things that we've leaned into quite heavily that makes Google very unique compared to their competitors, which is the way that they break down the resources and the hierarchies that are permitted within those environments. It all starts with a Google organization. The organization is the root node in the Google resource hierarchy, provides it's a top-level construct for applying policy. So if I don't want anybody to expose a public IP address on a VM or on a cluster, I can code that in policy and apply it to the entire organization. Within that, we have assured workloads. This is a unique container that enforces governance at a particular governance tier, say IL4, IL5, FedRAMP. Within there, we have the ability to provide more granular refinement of the resource hierarchy and the way that we apply policy. This is very, very important because my authorizing official may be willing to take more risks in development, but when it goes to prod, it's got to be locked down. I can operate according to IL4. However, if I'm in development and I know that the API that I want to use when I get to production is going to be available to me by the time I get to GA because it's on the desk at DISA waiting for approval, I can put an exception into my dev folder, give my researchers access to that so that when they go to GA, their workload is now relevant. It's not obsolete on day one. And then we have the project, which is the ultimate container for all of the cloud resources and the workloads themselves. So these are the building blocks that we work with to create giant ecosystems inside Google Cloud. It allows us to have multiple different governance pools within our overall organization and support workloads at multiple impact levels, concurrently in the same zone. For those of you who are familiar with working with AWS, the GCP project is essentially an AWS account. Imagine not having to manage 100 accounts anymore. Within the research environments, users access the resources using the same core capabilities we use to secure the operations environment, with policies modified to directly access the government's compliance requirements at each enclave. Again, GitLab is at the core of the ecosystem, providing the same Terraform configured security with repositories, branch protection rules, merge policies, etc., all codified and applied using Terraform. Individual repositories are configured to leverage GitLab's ultimate numerous security features to scan our code for vulnerabilities, provide dependency analysis, and detect secrets within the code base before they can be committed to main. In this example, we illustrate the use of folders to define the risk boundaries around the workloads operating at various stages of maturity within the IL4 assured workload boundary. As in operations, we use similar code-driven declarative approach for both the application in development and in deployment. This architecture allows us the flexibility to craft targeted, granular controls that address the research mission requirements, collaboration requirements, and risk tolerance for a given effort from our security and authorizing officials. We utilize GKE Enterprise, Google Kubernetes Engine, and Service Mesh to ensure that the core capabilities are in place to effectively segment the workloads within multiple cluster deployments, not only at IL4, but in deployments at all levels of the platform. We govern access to these resources accordingly using one of my favorite capabilities in Google's Enterprise Kubernetes. It's called Connect Gateway. Connect Gateway serves as the foundation for other GKE Enterprise features such as multi-cluster service mesh, policy management without requiring direct network connections to the clusters in much the same way that we use Private Service Connect. It's an API endpoint that you call to access the control plane on the cluster. It also provides us the ability to provide granular control to different parts of the cluster to different development teams securely. Development team admins are granted access to the specific namespaces within the clusters This isolation ensures that teams only have access to the resources that they need and none of the others. Connect Gateway enforces this using a role-based access control mechanism configured to the namespace. So this is what it looks like in practice. We connect to GitLab, we clone the repo, we do our work from a cloud workstation through Private Service Connect. This is for developers, admins, all different roles and different accesses can be defined here. And then when we need to push things into the cluster, we use the Connect Gateway. We can do the same thing for the control plane for the site reliability engineers. What else have we got? So we're supporting dev, test, and prod workloads in IL2, research, dev, test, and prod workloads in IL4, test and prod workloads in IL5. We have dedicated security operations, SIM and SOAR provided by Google SecOps, and we have a logs warehouse. We instrument these using core light sensors. Those of you in the IC are familiar with these. They inspect every single packet, collect the headers. We then use those to enrich the logs in the SIM and the SOAR. They also provide IDS services. There's not a single packet in our environment that isn't inspected anywhere on any of our networks ever. And then we ship all of our logs to DevCom C5ISR. This is what an alert looks like in our SOC when it fires. This is, for those of you who are familiar, this is Chronicle. The platform is 250,000 lines of code, developed and maintained over just 2 years by a team of just 8 engineers, full-time, 8. The key technologies that we couldn't have succeeded without include Google Identity, GitLab Ultimate, Terraform, Google Cloud DNS, Google Identity Aware Proxy, Google Access Context Manager, Google Cloud Workstations, Google Distroless and ChainGuard's Wolfie, Google Artifact Registry, Artifact Analysis, and Container Scanning APIs, Google Private Service Connect, and Google Kubernetes Engine, and GKEE Connect Gateway, and Google SecOps. All of this was again made possible by Dr. Dan Berrigan, lead of the AFRL's Worldwide Research Collaboration, Alexis Bonell, our CIO and our AO, David Shahady, Deputy Director of the Digital Capabilities Directorate, Randy Resnick, Director of the DoD's CIO's Zero Trust PFMO, my principal SRE, Jonathan Brown, and the staff at Mile Two, including Jeff Zeminski, Eric Brown, Zach Chadwick, Andy Garrett, and Chris Caldwell, Matthew Luce, who is our own personal superhero at Google, Svetlana Kelly, Alvin, and Dan at Citrano Public Sector. This is an amazing company. These guys were on the Chronicle development team originally. They are very sharp and some of the best SecOps people in the business. Andy, Zach, and the entire team at GitLab, Brandon Campbell here at Mandiant, and Gene Schaefer, Bernard Brantley, and Scott Mahan, the entire core team at CoreLight. Rather than just sort of review what I've covered over the last 40 minutes or so, I want to kind of illustrate one of the things that's possible in an environment like this. As I was developing these slides, I utilized a notebook LM feature in Google that we were able to deploy in IL2 to analyze my slides before I submitted to public affairs. I wanted to see if the AI was interpreting what I was doing correctly. This is what it came up with in conclusion to this talk. Hopefully it plays. And maybe not. That's it. I have 2 amazing people here from Google. If you have any questions, we're welcome to field anything you can throw at us.
Question about the potential vulnerabilities in the system. I'm sure you've uncovered vulnerabilities as you've been developing it. How are you addressing those? Are you looking at architectures to help fix and resolve those vulnerabilities?
One of the things that we found once we got most of the NIST 800-218 controls in place is that most of the vulnerabilities are actually in our supply chain. They're not in our code. Almost all of the vendors that we looked at bring risk to our environment. It's not coming from us. So I think this is a really important point. I'm glad you asked the question because throughout DoD's supply chain, we have a lot of vendors who are producing tools that are vulnerable. CISA started trying to address the issue through the secure software development attestations that they're asking developers to sign, but this is only a start. We have to have better visibility into the risk that the vendors bring into our environments, our operational environments, because just like I can scan them, our adversaries can scan them. And if they know that I'm using a particular code base in my ecosystem, they're going to know exactly where I'm vulnerable. For us, this is the starting point for the conversations with the vendor, and we're demanding better of most of the people that we work with by pointing out the vulnerabilities and helping them address the vulnerabilities in their own code bases before they license code to us to use in our ecosystem. Anyone else?
Yeah, I was just going to add something onto that real quick. So we also, after the design and build, and once John and the team, basically operationalized the network, we took a proactive approach to deploy one of our security validation platforms, which basically takes, all the threat intel from Google, from Mandiant, all the APT information that we have, and emulates those attack scenarios across the entire network to see if any of those attacks were successful or not. During the early stages, we found a whole litany of vulnerabilities, a dozen or so. Gave it back to the team for them to iterate, improve, secure more, and then we did another red team assessment using some more advanced red teamers to help even secure it even more. So that was in the other initial stages of how we found out some of those unknown vulnerabilities.
Yeah, and to add to that, I want to say again that our approach to both site reliability engineering and SecOps is to make those two parts of our operations teams collaborative. A lot of environments I see these days have SecOps in one silo and operations in another, and they play games of gotcha back and forth, and it's not constructive. It doesn't help to improve our security posture. In our environment, we broke that barrier down, and they work in a shared responsibility, shared outcomes environment, where things that come up in the SOC are immediately translated down to the site reliability engineers so that they can proactively implement changes to our controls to improve our security posture. So that collaborative relationship is also extended out to players like Mandiant and to folks like the DoD CIO's office, where we've actually engaged them to bring people into our environment and try and find problems with it so that we can get stronger together. So, yes?
Hello, my name is John. Thank you, gentlemen, for the talk. I'm a surface warfare officer by trade, so not an IT professional. I'm trying to understand with this cloud, what kind of capability does it give us? Will we be able to access it and upload DoD data and do some machine learning on it? Do we have access to Colab, Gemini on the cloud, or those type of capabilities?
I'm going to pass some of this to Andrew, but I will say this. If you're in a DoD mission space, we are actively collaborating with a number of other partners across the entire ecosystem. And we are happy to introduce you to folks like Dr. Berrigan and to have folks figure out how to work together with you collaboratively. We're already working with other parts of the Air Force. We're working with the Army. Yeah, absolutely. So if you give me a card or we connect, I can connect you to the right people inside the lab.
Thank you.
Yeah, absolutely.
Hi, I'm Tim Ogden from Blue Ivy Partners, and we've been working with the Air Force on some software factories over the last 5 years. So this is really impressive. Great on the execution. You've done some things we haven't seen in many other places. So I'd like to ask you maybe a few questions. What mistakes did you make along the way? What did you error correct? You chose something, and then you decided to go to another path. Second, what is your vision for the next iterations? What do you continue to do in the design and vision of what you have here? Because it seems like you have something really, really strong and great. What were some of the options that you considered as you chose the things that you showed here on your final slide? And when would you not asking you to reconsider, but how do you reconsider the other alternatives?
On the first part of your question, what mistakes did we make? I think the first one was more of kind of a tactical mistake more than an implementation mistake, and that tactical mistake was not skating to where the puck is going earlier. We knew that when we got started that there were a lot of Google capabilities that we wanted to use that were stuck in accreditation. And rather than lean into those capabilities up front, knowing that we had a long road to sow ahead of us, we tried to implement what was allowed for us in that moment. But we weren't going to GA yet. So it didn't really matter if it was accredited or not. And so in hindsight, had we taken a look at the accreditation trajectory and aligned our development so that it would intercept with that at a point somewhere on the calendar out downrange, 2.5 years, we would have lost less time in the first 6 to 8 months. This is particularly the case with our leaning into GKE Enterprise. GKE Enterprise over traditional GKE that most people consume, and the addition of service mesh and all of the kind of zero trust goodness that comes along with all of that, it would have saved us 3-4 months of toil that we had to do subsequently. But in many ways, I'm not disappointed that we didn't make that switch earlier, because we learned a lot through the process. There's a lot of little mistakes that add up to a lot of learning. I think the one thing that I'm proudest about my team is that they've kind of embraced this idea that it's okay to make mistakes, because that's where we learn the most. And I'm happy to fail fast. And thankfully, Dr. Berrigan's given us, a lot of cover fire over the last few years. And so we've had a pretty safe space to operate in from that standpoint. We could have brought SecOps on earlier. We thought that DevCom could do more for us than they do. I think they're under-resourced, and in research we needed to run with scissors, and we didn't quite understand up front that having our own SecOps was going to unlock our ability to run with scissors more. It was gonna make our security team, the AO, a little bit more comfortable with us getting out over our ski tips, because we had the monitoring and the security operations and a process to alert them to incidents as they were happening and let them feel confident that we were addressing them in real time. And that's really that's all they care about. I mean, most of ATO is a box ticking exercise, and we did a lot of stuff that was in the spirit of that checkbox, but didn't really specifically hit it. And the other thing is establishing that early communication with the AO and having them understand what our core philosophy was and how we were approaching the problem, and acknowledging that it was different, new, and something they hadn't seen before, and getting them comfortable up front. I think having that conversation earlier would have been more helpful as well. So. Exactly. Where is that the question you're asking? Where do we go next?
I got a few things if you want.
Yeah, please go. Andrew.
Yeah.
Andrew's working.
You can,
he's working so close with us every day. I can't say enough for this team. So
So maybe three things on where we're going. So the first, no solution is perfect at the beginning. And so, we're taking the red team findings that came out of that purple team assessment, and we're taking it back to our product team and creating that partnership of making improvements as we continue to go. We were also talking yesterday about like reducing noise in the environment of, rather than having collectors in attached to each resource, what can we do to have more native API access to make the system more efficient? John mentioned that we got 100% pass rate on the first try with our zero trust approach with the DoD Red Team, but they didn't test all the controls, right? We went for target level at the beginning and exceeded that. And so they're going to circle back and do a second assessment and complete the advanced for all 152 zero trust activities. So that's a really exciting next step. I'd say the last one, Dr. Berrigan and Jonathan have been looking at how can they take this basis, which is really tested at kind of IL5 controls, and push the limits of zero trust implementation, looking at sensitive data sets and how could they do more and more with the platform from that basis. So.
got about 5 more minutes. Any other questions?
I'll ask a quick one. So I think I understand the technology. I'm more interested on the people and process side. So it sounds like you had like a core group of 8 SREs. Can you talk a little bit more about how that team like interacted with the research teams? Like you had your 4 roles, right? You have your sort of your reviewer, were the developers and the research teams playing those first 2 or 3 roles, or the SREs, were they the reviewers? And can you talk about that a little bit more?
So we kind of leaned into this concept that Google developed called readability. And so there's a million Medium blog posts about it out there, but they have an internal mechanism that they use to like gauge whether a developer is good enough to be reviewing code for others. We don't just limit that just to the SREs. I mean, AFRL is an amazing place. We have more PhDs there than you could throw a rock at in the Superdome, and you'd hit one every time. And these guys are smart. They know what they're doing, and a lot of them are very, very good software engineers. And so, we have a way to gauge whether or not they should have readability in their own code base, or if for many of them infrastructure as code is a new thing. So coding in HCL is not their forte, but they may be amazing in C. Again, it's a shared responsibility situation where the site reliability engineers always take ownership and custody of the underlying infrastructure all the way up to the runtime. And then the application stack itself that lives on top of that, if it's custom code, we're assigning, kind of maintainer roles to the people who are developing that. And it's watched over. And like I said, we have many different ways to, run different pipelines for merge requests and things like that. So we see what's happening in the code base. But by and large, and that also goes for, to be honest, other contract teams. You might have somebody in there working with a researcher from Booz Allen or from SAIC or whoever, but they're all coexisting in the same ecosystem together. And I think that's really ultimately the power of what we've done is we've created an environment where folks in the DIB, SAIC, Mandiant, folks at the DoD CIO's office, they all live in our code base with us collaboratively. And so we all see each other's work and we're passing information back and forth, and features are coming from like sometimes the most unexpected places, and it's great stuff. So, yeah. I guess that's it. I also just want to say my CEO, Jeff Grayley here from Mile Two, is here, and I just want to say thanks because also, you have provided a great place for this team to blossom, and we really appreciate it. All right.
Hey, Lieutenant Commander Falk from Nautic, Miser Weapons School. Have you already seen efficiencies gained when you get to the product transition as when they for them to go work on the higher ILs with those more exquisite data sets, whether it's with Clairvoyant, Sav, Wintermute?
100%. Yeah. Just because we've actually measured it, this platform's saving over 500,000 hours of research and development time a year for the lab. It's just by providing access and getting things accelerated. One of the things that I've observed over the last few years is that we tend to move things to higher levels of classification too quickly. And as a result of that, the early work, the work where you need to make some mistakes to figure out what the right direction is, can't happen very efficiently. And so one of the things that's really nice about this environment is that we have this progressive mechanism, or this architecture that supports this progressive maturing of workloads to the point where you can work with either synthetic data at IL4 or data that may be less sensitive at IL5, and then when you're ready, you can promote those workloads into an environment because they're all cloud native. They're all, you're not maintaining state in any of our application stack, and so you can deploy it into a Kubernetes in Podman or something, and inside a boundary that's completely cut off from the outside world at TS, and then bring sensitive data to it. So that really accelerates that flow and that process. Yeah. All right. Thank you all for coming. Andrew and we'll all be down at the Google booth. So if there's any more questions, I'll be there for the next couple hours. Feel free to come by. All right. Thank you.